last thing I want to sort of transition back to is this notion of montage, because I spent a bit of time talking about frequency. Let's talk a little bit more about montage. If you remember, the first aspect of dose is where you put the electrodes, right? How big they are. And it turns out that it doesn't have to be only two. If you make the electrodes smaller, and we call these high definition electrodes, you can put a lot of them on the head, and you can connect them to multi-channel stimulators to generate much more interesting configurations. And I've talked about that in other videos in the context of tDCS. I want to just very quickly extend those same concepts to tACS, all right? So again, high definition tDCS is use of high definition electrodes, which are just small gel-filled electrodes. And you can imagine that you have a lot of degrees of freedom here, right? Because I have now all these electrodes. Maybe I choose to use this one, this one, this one, and this one, right? And so there's a lot of ability to optimize this for the purposes of targeting. Now, each electrode doesn't need to have the same amount of current. I could have +1, +1, and -2. Or +1, +1, -1, and -1, right? The only thing that has to happen is that the total, right, has to add up to 0. Now we have to be a little bit careful here, because in the context of tACS, there isn't just an anode and a cathode, right? They're swapping, right? So it's more like +1, +1, -1, -1, and then -1, -1, +1, +1, right? And so who's playing the anode and who's playing the cathode is actually switching. So that's one thing to be aware of. And again, any waveform can be used with high definition, but including tACS as well. So let's think about that a little bit. One of the nice things about high definition in general, high definition tACS, is you can get one device, one headgear, and with that you can do an almost infinite variation of not just frequencies, but spatial targeting as well. Now you can say, well, okay, but that seems kind of confusing. Like, how do I know if this should be +1.5 and this should be -0.4 and so on? So this is something we and other engineers have been working on for a long time. The good news is there's software available to help you figure out where you should put the electrodes to target a particular brain region, different optimization algorithms. Some of them are commercial, but some of them are open source. Some of them are easier to use, some of them are harder to use. Again, they're all based on a single piece of device. They all operate within a scheme, I should mention, where TES and high definition TES are very well tolerated, but as I'll show you, can even be more focal than TMS. If you dig into it, you'll find reports talking about the importance of individualization, which can be done with these modeling and high definition. You may find literature on combining stimulation with EEG. I mentioned that the brain generates its own oscillations and that you can record those with an EEG system. What's really nice about high definition is that these electrodes, while they're not EEG electrodes, are very similar to EEG electrodes, and so you can have equipment that integrates, right, essentially interlace recording and stimulation sites. So high definition tACS lends itself very well to integration with EEG, which is interesting for a lot of other reasons. And again, I'm just flashing these issues here very briefly. Okay, I want to talk about one montage in particular. I've talked about this in my other videos in the context of tDCS. I'm going to review it very briefly and then explain what it means for tACS. And that montage is the 4x1 ring montage. So in the case of tDCS, what we have is we have 5 electrodes, 1 in the middle, 4 around. And the notion is that the middle one sets the polarity. Let's say the middle one is the anode. Okay, this is DC. The 4 outside ones are then the cathode. Now, if this one is +1 milliamp, in order to balance the current, each one of these 4 outer ones have to be -0.25 milliamp. And so you can see that we have more current in the middle one than in the outer ones, and this produces this more preferential unidirectional form of modulation, where red here shows you the region of inward current flow or soma depolarizing. And again, I'm going through this quickly because I've covered it in other videos. Now, if we flip the polarity of the electrodes so that the middle is now the cathode and the outside is now the anode, the direction of polarization flips as well. So now we have mostly outward going current, right? And this is soma hyperpolarizing. So this is the 4x1 montage. It has a lot of variability, a lot of flexibility. So you can put this 4x1 over any cortical part that you want to influence. And by making the ring tighter and tighter, the ring, I mean the 4 electrodes on the outside, you can make it more and more focal to the point that 4x1 high definition can be as focal, right, as TMS. This notion that the skull is somehow an issue turns out not to be the case. So 4x1 HD, so 4x1 is the montage, high definition is the electrodes, tDCS has been extensively used, and so has HD-tACS. What happens with HD-tACS? You still have 5 electrodes, and you still have the situation that the polarity of the middle electrode and the polarity of the outer electrodes is opposite. But that polarity is no longer fixed. You start with a situation where you start with the middle is the anode, the outers are the cathode, and then you switch, right? So now the middle is the cathode, the outers are the anode, right? And that's one cycle. And then you switch, and then you switch, and you switch. What does that mean? It means that you have a region of the cortex that you control, right? Any part of the cortex. It can be focal, right? And you can produce this more unidirectional polarization in that part of the brain. And so if you look for papers using 4x1 high definition tACS, you'll see that these are papers which identified a part of the brain that they were interested in. They positioned the 4x1 over that part of the brain, right, with the middle electrode on top of that part of the brain, and the rings are sort of defining the region of influence. And then they drove those electrodes with AC stimulation at a particular frequency. So you could have regional targeting and frequency targeting. And there's some really elegant work using that. Okay. That's where I'm going to stop. I've tried in a way that is technically correct, but hopefully not too overwhelming, to give you some intuition about how tACS works, not just the most simplistic notion of it, but a more nuanced understanding of how to deploy tACS. If you're interested to learn more, you can look at other videos on my channel. Some of them focus specifically on the general class of subthreshold stimulation and how it works. Some of them focus more on how you can position the electrodes for different purposes, and hopefully other things that you will find useful. Thank you for your attention.